Hi, everybody. My name's Patrick Martin, and we're here to talk about bringing your awesome mobile game to Google Play Games for PC. Now, you've already heard why you should do this, thanks to the earlier session, Unlock Seamless Gameplay Across Mobile and PC. And you've heard some of the tools that will help you achieve this goal in introducing the new emulator. But just enabling your game to run on the emulator is only part of the story. If you navigate to the checklist we have published on developer.android.com, link in the description below, we'll cover using high-resolution assets and textures on Windows, supporting Windows aspect ratios, scaling your UI elements for larger screens, rendering at 60 Hz, ensuring smooth audio playback, and no, this never really is an issue, supporting mouse and keyboard input, and integrating the Input SDK. Oh, and in the next talk, give your players seamless continuity across play surfaces with PGS. You'll learn all about cross-platform play. So first, let's take a look at high-resolution assets. Your first inclination might be to pick up a Pixel 7 Pro and see that its resolution is 1440 by 3120, or roughly 1440p. This is fairly high resolution, and thanks to the Steam Hardware Survey, we know that the most common desktop resolution on the PC is 1920 by 1080, which, why do I want high-resolution assets? 1440 is definitely more Ps than 1080. Now, we've run a bunch of player sessions during our beta period, and players say things like, the graphics are a little chunky, or it doesn't quite look high-res. A general body of complaints along the lines of triangles and/or pixels are big, and I don't know why this bothers me all of a sudden. And the reason is kinda staring you in the face when you think about it. I mean, this long into the talk, and half of you probably already have thought about the answer. Even though the resolution the player is playing at is lower, the screen size is much larger. I have a 34-inch monitor at home, and even if the resolution was 75% that of my phone, every single pixel accounts for so much more of my experience. Now, when scaling up your assets, you should be aware of memory constraints. Google Play Games on PC may boot with as little as 3 GB of RAM. Your limit is closer to 2 GB if your game can't produce 64-bit x86 binaries. Since this is an Android environment, when you run out of memory, you go straight to SIGTERM right away. But the good news is that depending on the amount of RAM available at the system level and the size of your page file, the emulator may get substantially more memory for you to grow into and really show off your high-res assets. When deciding what to spend time on, I feel like oftentimes increasing your poly count can go a long way to addressing players complaining about low-resolution graphics on PC without doubling or tripling your texture sizes. Could be players are finally actually noticing these giant flat shaded polygons. Now, when you look at improving textures, it can get a little tricky. You'll want to compress your textures, and ETC1 and ETC2 formats are technically supported, since this is an Android system guarantee. But because these formats aren't supported at the PC driver level, Play Games on PC will typically decompress the textures in memory, which is often not what you want. DXTC and BPTC compression formats are natively supported on PC hardware and will get passed through to your GPU directly, although I recommend attaching a graphics profiler to the emulator itself to validate what the emulator emits when verifying your port. Oh yeah, remember that this is a PC and not a phone. If you wanted to post-process your game a little bit more, you don't have the same performance ceiling as you do on mobile, especially since you're probably not running on a tiled GPU. So feel free to sprinkle in a little bit more bloom or depth of field to mask any chunky textures or models you have laying around. Go on, you've earned some extra compute. Finally, you have some super awesome high-res assets. You've crunched down your textures into the ideal format. You've plumbed the texture resolution way up. How do you get the assets into your game? Some engines just spit out an archive file that you have to figure out how to serve at some point. Do with that what you already do already. But Play Games on PC fully supports play asset delivery. This means that with a few simple rules at build time, you can designate assets as either install time, fast follow, or on demand. Then you can use a series of device filters to decide what packs get delivered to your device. See this video for more information, link in the description below. And remember that how much of this you do and what tricks you use is essentially an aesthetic choice that you make. Players will start to notice low-res assets on larger displays, but I'm a big fan of retro and pixel-style games. I'm not telling you that your 8-bit sprite has to make the jump to 32 bits in order to run for play games on PC. But what I will tell you is to support PC aspect ratios. Specifically, either 16:9 or 9:16 are required. So we've done a lot of testing of a lot of games here. With Android 13 and Chrome OS, it's fairly common for Android activities to launch in a manner that can be resized, with different rules on each platform. Seriously, if you haven't tested your game resizing, go do it. It can be pretty awesome when it works to have a light puzzle game sitting next to a video stream on a large screen Android tablet. Now, we found that games in particular, though, can sometimes behave erratically. And it's frankly not surprising. Game devs often have to build up their world from the bottom up. I worked in a custom UI system where every time you called layout, everything moved to a slightly different spot. Seriously, a last-minute crunch before ship bug I had was solved by calling layout exactly 3 times, with a big old comment like "do not change" thrown in above it. So instead of spending this slot of the talk going over how picking works in 2D and 3D, or when to rebuild your projection matrix, Play Games on PC opted to simply choose a single resolution and aspect ratio for the entire run of your game. The window can resize diagonally, but pixels remain square, and you always have the same number of them to fill. It doesn't matter what configuration changes you listen to, or whether or not you say that your game is resizable, you get one logical size. And this actually turns out to be the right call for many, many games. You don't get the fallback behavior of a game randomly relaunching as you resize it. Touch targets stay where they need to be, and resizing and toggling full screen just mostly work as you expect when using a PC. Now, the exact resolution that's chosen is a work in progress. We are beta after all. It's probably roughly 1080p, but don't make any assumptions. What likely won't change is what aspect ratios you need to support and how to choose them. But your first question to answer is my game a portrait mode game? And if so, do I want it to stay that way? It isn't just the easiest choice to leave your game as portrait, but if you suspect that your players often play your game whilst doing something else and your UI is laid out vertically, this is the best choice. Remember that the aspect ratio cannot change once your game launches, so full screen will give a player these giant black bars on the side. More bars than game if you have an ultra-wide monitor like I do. But if the most space-efficient layout for your game is portrait, this makes it super easy for a player to position your game next to something else. This is especially useful for idle games that you want to passively monitor, or puzzle games that you keep open as you binge that new streaming show. Just make sure that you don't support any landscape aspect ratios. And why is that? As of this writing, Play Games on PC supports 21:9, that's me, 16:9, 16:10, and 3:2 aspect ratios. When your game launches, it will look at the dimensions of your primary display and choose whichever aspect ratio it believes best matches your monitor. If you want your game to play in portrait, then there are just a handful of folks with vertical monitors who will see your game as intended. But a big reason to bring your game to PC is to let the player be immersed. This means that a player will want to blow up your game to full screen and really get that nice panoramic view that you've put so much time into building. Now, if you leave your game as portrait only, this again will be more black bar than game on a 21:9 monitor. But if you build in support for these PC aspect ratios, I'm betting your game finally starts to look like those art mocks you greenlit way back in pre-production. So back to our checklist. This next line item might seem a bit odd, but we highly recommend that you scale your UI elements for larger screens. Someone reached into a hat one day and pulled out the stat that the HUD should take up no more than 20% of the screen. For many games, I probably agree with this. Get those life bars and whatnot out of the way so you can immerse the player more in the action than before. Remember that you've gone from something like a 6.7-inch screen to some size well north of 20 inches. Many games on their first pass will look, for a lack of a better word, just goofy with these large touch targets. On the other hand, If you were struggling with text legibility before, just leaving everything the size it was could be an accessibility win and unlock a slightly larger market than you were expecting. So this is really a per-game decision, but I highly recommend that you sit down with your UX expert when porting to PC and consider whether you might want to tweak some sizes. Now the last two changes I'm going to cover are to let your game run at 60 Hz and make sure audio doesn't skip. For most folks, their frame rate is just a matter of raising their 30 Hz cap to 60. For PC players, they don't really have the same battery considerations that a mobile player will have, and there's plenty of compute headroom to spare, although you could possibly push back if you have some aesthetic reason to limit the frame rate, say to match hand-drawn animation frames, or perhaps your physics system just becomes unstable. To my knowledge, games haven't really struggled with this. Similarly for audio, since we are testing games, lagging audio will likely come back as a rejection. But to my knowledge, most of the issues were with early versions of the emulator. Most games I've worked with have had smooth audio playback. But wait, there's more! Here to talk all about input on Play Games for PC is Gerald.
Thanks, Patrick, for introducing the great things for Google Play Games on PC. Hello everyone, I'm Gerald, a developer relation engineer of Google who focuses on Android gaming. I will walk through one of the important tasks of migrating Android mobile games to PC, its input. Input will be changed from touch screen to mouse and keyboard, and the support of Android APIs. First, let's deep dive into the differences between mobile control and PC control. Users are using the mice on PC devices as well as using finger on mobile. The mouse and touch look similar, but they are different. Understanding the differences will help developers build high-quality games with the native PC experience easier, especially for developers without too much PC development experiences. With touch control, the action is to touch on the device surface and the coordinates are absolute coordinates on the surface. Google Play Games support the simulator mode, which works as a touch if your game does not need complicated mouse control. And Google Play Games also support PC mouse mode, which works as a real PC mouse. With the mouse control, a user moves the mouse and can see a pointer and the coordinates on the system desk, which is similar to the touch, but mouse is more complicated. For example, imagine that you are playing a shooting game. You don't always need a pointer, and you can move the mouse to the right again and again. The pointer is not required, and the coordinates could be infinite if it's absolute. So getting a relative mouse move offset between frames is more rational in the mode, which we call pointer captured. The button status is also different for each mode. Modern mobile devices are usually multi-touch devices. It means that devices can accept multiple touch points, but there are no actual differences except for indices. Users typically tap to control the devices, but mouse has different specific buttons, including left button, right button, and while. Each button has a separate status. Mouse clicking is the equivalent behavior of typing, but hover is an additional behavior. Touch screen input transition mode is used by games with simple mouse actions. The code treats the mouse as the same as touch. Android on-touch event will be triggered when the user presses down the mouse left button. Additionally, developers are able to receive the while event in the ungeneric motion event to handle the mouse while action. PC mouse mode can handle more mouse actions like red button clicking and mouse hover. In the ungeneric motion event callback, the code can handle these behaviors, which are important for a native PC experience. Pointer capture mode will not show a pointer, so there is no hover status. You can get the up or down status of all mouse buttons and the relative coordinates. The listeners of on-touch event and on-generic events are used here for different purposes. Some of the data are retrieved by on-touch event, and other parts are retrieved by on-generic events. I will show you the relation between listener and data here. Blue lines are simple to understand, and the yellow lines show the PC mode coordinates are retrieved by touch when pressing, but retrieved by generic motion when hover. Request and release capture method of View class can be used to control the capture. Let's see an example of mouse pointer capture. If the code does not call any of the method or call release, the pointer is shown, and you can see the coordinates are absolute values. But the pointer will be hidden, and the coordinates will become a relative value when request pointer capture is called. If your game needs to take full control of the mouse cursor, such as first or third person action game that map mouse movement to camera movement, View.request pointer capture can help you achieve the goal. There are some requirements for the Android View which can capture the pointer. Let's show a code sample in Java programming language. First, it should be flexible. You can use code to set it as true or use manifest file to configure it. Here, we use the code to set it at runtime. The event of pointer capture is received by a different listener. So, please use the setOnCapturedPointer listener to set the callback function. The class of motion event is the same as the motion event class in the code of touch event. But XY coordinates will be relative values, so it usually needs a different handle logic from touch event. You can write Kotlin, Java, or Android native code for implementing the pointer captured behavior if the behavior is not supported by your current engine. Keyboard control can be implemented through the Android onKeyDown and onKeyUp event. It's pretty simple and supported by mainstream game engines. IME, which is important for most languages in the world, is supported by Google Play Games without any change in the Android code. But on this platform, users will change languages on the Windows level. They can select IME in the Windows taskbar and use system hotkey to change language and toggle IME. Left, Alt, plus Shift are usually used for changing languages, and toggle IME hotkeys could be very different in different languages. Using the same hotkeys for game control will enable IME unintentionally. Meanwhile, if a game implements keyboard control and complicated mouse control. The Google Play Games Input SDK provides a unified interface from which players can discover the mouse and keyboard binding for any game they wish to play on Google Play Games, and the key remapping feature is coming. At the end of this session, let us have a recap of the input. The first, we explained differences between touch and mouse plus keyboard. The second, because of the differences, there are 3 modes of mouse control in the Google Play Games on PC: transition mode, PC mouse mode, and PC mouse mode with pointer captured. The third, keyboard and AME. Keyboard is easy to implement, and be careful about the AME hotkeys. The last one is the Input SDK, which is a unified interface for control guidance, and there will be a remapping feature which is coming. You can visit the link to learn more about the input of Google Play Games on PC. Thanks for your time today. Hope you have a great journey on the Google Play Games on PC platform.